All right, so there's a little outline of the things we'll cover in 12.2. And I'm going to go with the definition or an idea of what a vector is. Vectors, it's a quantity. It has both a force and a direction for the force. So, looking in your book to see how they've defined this, but it has vectors. This would be just kind of a property of vectors. They have both a force which would be a magnitude and a direction for the force. We'll model vectors with a half line. So on a piece of paper, we'll model vectors with a half line. So there's a dot on one end and an arrow on the other end. So I'll write that. We model vectors with a half line. And so from geometry, half line would be a ray. So I'll say where there is a dot on one end and an arrow on the other end. So I'll draw a little picture. So here's my dot and then an arrow. And the dot is called the initial point. And the arrow is the terminal point. Where the arrow is. And in physics, you might have used something else. Or in this class, we might use something else. Initial point could be the tail. So the initial point or the tail. The terminal point, or we might say the tip. How do you know if two vectors are equal? The same length and same direction. So it doesn't matter where I would position it on my paper. If two vectors have the same length and the same direction, then they are equal. So I will the arrow, the where it's pointing toward. So two vectors are equal if they have the same magnitude, which is the length. I'm just going to put length. The same length and the same direction. And again, let me write what I just said, that the length is also called the magnitude. The length is also called the magnitude. And I'll draw two vectors. I'm going to say that they're equal. I didn't bring my ruler with me. Maybe I should have. Pretend these are just in the perfect same direction. I'll call this one vector V. Now what we'll do, in the calculus book, sometimes they'll V with an arrow on top for vector V. You might have seen some other notations. V with what? A little, call it maybe a hat. That's good. You can do that. Well, here I have vector V, and here is vector W, and I'm going to draw it as best I can. Same direction, same length. I called one V and I called one of them W, but if they're in the same direction and the same length, I can say that they're the same vector. I can say V equals W. Vector V equals vector W. You could also write vector V is V with that little hat symbol, W. It does not matter to me what symbols you use for the vectors. I'm kind of curious about that hat symbol. Is that supposed to only be for I, J, and K? Absolutely. It may be. See? Yeah. So, all right. But if that's when two vectors are equal, and what we'll do is we will put the vectors on either the XY grid or maybe into R cubed, and we can place them there. So I'll write that. So we can place the vectors in R2 or R3. Now if you're in R2, it's a two-dimensional vector. If you're in R3, it's a three-dimensional. I don't know if a vector can be three-dimensional, but it's in 3 space. So, and it should be kind of clear from the problem whether we're talking about whether they're in the XY plane or whether they're in 3 space. But they'll go back and forth in the book in chapter 12 with this. Sometimes it'll be in R2, sometimes it'll be in R3. It's easier for me, of course, to sketch something in R2. So I'm going to do a little example.